Hi guys, my name's Aman and this is the second video in the Finance in Python series. In this video we're going to be going over financial indicators and programming them into Python. Financial indicators are basically mathematical tools that analysts use to try to predict stock prices and what's a good time to buy or sell a stock. And I think we'll start off with simple moving averages. Moving average. So let's say you have a time series data here, and all of these dots are data points. What the simple moving average basically does is it takes the average of these 3 points first. Then let me change colors. The average of these 3 points. Then the average of these 3 points. Then the average of these 3 points. Then the average of these 3 points, and so on. And it takes each of these averages and creates a new data point out of them. And these new data points are our new time series. Now you can tell that the length of the second series, if let's say the time period for which you're taking the average in each of these moving average scenarios is t, then you can see that the length of this new time series would be the length of the initial one minus t minus 1. Now that's fairly simple as a concept, and with this just gives you a kind of a smoother version of the actual stock price graph, and it also helps you spot trends before they actually happen in the stock price graph. If for example you look at the simple moving average over 5 days versus over 20 days, you'll see that the 5-day one will be more reactive and the 20-day one will be less reactive. And if you see if you see them cross over at any point, you know that this predicts that something's going to happen. Like if the 5 moves below the 20, that means that the stock price is going to drop. If the 5 moves above the 20, like let me give a better example with that. Let's say this is the 5-day stock price in blue, and in yellow it's the 20-day stock price. This crossover point indicates that at this time period that the stock price is going to fall, because the more reactive one went below the less reactive one. And if the vice versa happened, it would mean that the stock price is going to go up. A better tool than simple moving averages for doing all this, however, is an exponential moving average, which is what you use in a very important financial indicator called the MACD, which we'll talk about in a bit. So the exponential moving average is basically the same idea as before, but this one places a higher weight on the more recent data points, which makes it even more reactive than a short-term SMA. A better way to phrase that would be this: for the same time period, an EMA would be much more reactive than an SMA. Now, let's say you're taking an EMA over this time period. If let's say we take an EMA over these 3 data points, let's call them T1, T2, and T3. Then you'd be multiplying each of these with a weight, and dividing it by the length that you're taking the average over. And the thing here is that W3 will be greater than W2, which will be greater than W1. Now, it's called exponential moving average because W3 is exponentially greater than W2, which is exponentially greater than W1, which is basically smoothing divided by the 1 plus the number of days raised to the power n, where n would be the distance from the current data point. So for W1, which is 2, okay, it's basically the distance from the current data point plus 1, because W1, which is 2 points away from the current data point, which is T3, would be this smoothing into 1 plus days whole raised to the power 3. And it would get lesser, and it would be 1 for the current data point. The smoothing is normally taken to be 2, and if you increase the number, it'll be more reactive. If you decrease it, it'll be less reactive. So I can show you the graphs for how that would be in the code. And the formula we use for calculating EMA is basically EMA of T is equal to value of T into the smoothing by the 1 plus number of days. We can call this n, the 1 plus number of days, plus the EMA of T minus 1 into 1 minus smoothing factor plus the number of days plus 1, and that right there is a formula. Now the MACD, which is not McDonald's, is MACD, is basically an indicator which subtracts the 12-day exponential moving average from the 26-day exponential moving average. And as you can tell, this is basically a crossover idea again. So if the EMA 12, given in blue, rises over EMA 1, EMA 26, my bad, then you know that the stock price is probably going to go up. That's that for exponential moving averages. And before I jump into the next two indicators, which will be RSI and MFI, which are the relative strength index and the money flow index, I'm going to go over the code for the exponential moving average and the simple moving average. Hi, so now we'll be coding in the EMA and SMA in Python. So the imports are basically the same as last time. We can just continue on from before. There's no problem there. And so let's start by defining a function. So we'll define the SMA of a certain data series and a time period t. And then we can create another empty array. And for I in range length of x minus t, because as you remember, the length of the data series is actually the length of x minus t minus 1. We'll put the sum equal to 0. And for j in range t, we add to the sum the current value in the data series, and we append s divided by t, which would be the average, to the empty array, and we want to spit out our array. So that's relatively simple code. And while this runs, wait for it to run. I think we're gonna have to run the old ones again, so we'll just do that. Okay, so now we can try to see our SMA function, see how it works. We'll do it on the same data set that we've been doing everything on till now, which would be the close prices for Facebook. And basically the same idea. And I forgot about that. Let's do a 20-day average. And again, this data looks kind of pointless, so we'll plot it out. Which makes everything look much nicer. And there we go. You can see it's a much smoother version of this. If you want it to be less smooth, instead of 20, we can try taking a 5-day simple moving average, which carries over more of the intricacies from the original graph, as you can see. I'll plot the SMA, EMA, MACD, and the original thing in the same graph together later on, so you can see that. But first, let's define the exponential moving average. So again, x and t, that's what we'll define. Same idea as before, we create an empty array to which we'll append values. Now here we need to have an initial average, because for the first average in the exponential moving average, you take the simple moving average. And then you use the formula which I discussed earlier. And for I in range t, a plus equals x of I and then we can do a is equal to a by t just to make it shorter, and y dot append a. Or you could have instead just y dot appended a by t over here instead of doing these two steps. Actually, that is what I'm gonna do. Seems more consistent, so we'll do that. And then inside this, we're gonna define another function which I'm gonna call EMA2, which is value and the exponential moving average from earlier, and it will return 2 into the value given divided by t plus 1, which is, well, as you remember from the formula, plus 1 minus 2. 2 is the smoothing factor, by the way. We'll change that around and see how that affects the graph in this video as well. T plus 1 and this whole thing into E. And I think that you can put these inside brackets as well, just so that it looks a little neater. And after we've defined this function, we do a for j in range length of x again minus t, y dot append EMA2 of x of t plus j, comma y of minus 1, which is the last value in the y table, which would be the previous exponential moving average. And then we just return y. This seems to be, yeah, that should be fine. So we can define that, and then we can do the same thing as above, except that we can do it with EMA now. And this is the exponential moving average over 5 days is quite sharp. Can change it to over 20 days and see how that moves. And we can try changing this value here, which was your smoothing factor, to something like 5, which is very high, and see how that affects this again. You can again see this is sharper. I feel like the difference would be more noticeable with 5, and here you can see with the super high thing, it practically mimics the original data. And we'll move it back to a smaller number, to something more like 2. And you can see that it's less accurate to the actual thing now. Now the last thing I want to do is show you the MACD and plot all these graphs together. So I think the first one we'll do is plt dot plot df of, oops, we'll just do that. Then plt dot plot SMA. Think I'll just copy paste this and then change this one to E, and maybe do this over 10 days for both of them. And plt dot show, which basically plots them all in the same graph. And over here you can see, I think maybe the data size is a bit too big for us to notice this properly. Maybe we do need to take a smaller sample size. We can try with that as well. But as you can see, the green line seems to be following more closely than the yellow line, which means that the yellow line is the simple moving average. And you can tell here, let's say, like, to be fair, that since these are two different types of moving averages, this is not where you would ideally be doing this. But you can see when the yellow crosses the green and rises over it, the stock price, like, which is around over here, and the stock price starts rising after that. So you can see that this could be a useful indicator over here. And over here you can see when it dips below, it's already falling down, but this does give you an indicator that's going to continue to fall down. And again over here, when it rises up, you can see that this thing starts rising up. So you can see that it's a relatively useful indicator, even if you're using two different kinds of indicators. But the better way to do this would be, so I'm just going to copy paste this entire thing over here, and we change this to EMA, and we make one, let's say, a 12-day and the other one a 26-day. So this is basically the MACD indicator. And over here you can see when the green dips below the yellow, or when the yellow rises above the green, better to say, it gives you an indicator the stock price is going to rise. Over here, when the opposite happens, you can see that the stock price did dip below. Over here again, you can just look at this graph and try to figure out all the things for yourself. And you can see that this is in fact a useful indicator.